This is Audiommunity, a podcast about our body's never-ending fight with the outside world.
Hi everybody, it is January 29th, it's a Thursday. This is Matt from immunity.org, and I am recording my first ever minisode today. I'll admit it's a little weird. Usually we talk to each other. Hopefully we have some sort of rapport that people are enjoying. I know that we like recording them, but what we found is that a slightly more flexible format might be in order, and so one of the ways that we're trying to address that is by having these small minisodes, maybe once a month from each of us. I know that Kevin has already sort of described that in his minisode, or at least from what I've heard. I haven't heard it yet. So the way that I hope that this will break down for us is I hope that we'll have a pretty good discussion, as we usually do, around some sort of paper, and then each one of us will either take current topics in immunology or slight extensions of the paper that we talked about a lot. I'm hoping that it's just a really nice flexible format. We can sort of just talk about whatever we want. I'm pretty sure Kate was going to be talking about the immunology of Twilight and vampires. I hope that she follows through on that. So hopefully they're a little bit lighter, a little bit more fun. And what I'd really like to do is I'd really like to talk about general concepts. I don't want to get too bogged down in gigantic, scientific discussions and validity and things like that, as I think we sometimes do in some of these talks. One thing that I want to start with today, and I want to start with it just because it's come up a couple times now, and it came up again in the last episode. And in the last episode, if you haven't heard it already, we were talking about a paper by Noel Pauly titled Staphylococcus Aureus Infection Induces Protein A-Mediated Immune Evasion in Humans. So in that paper, we're discussing a specific Staphylococcus aureus protein, and we do a small introduction as to the seriousness and the widespread nature of Staph aureus. As a brief overview, it infects a whole lot of people. That being said, most people are colonized with it naturally. We tend to have it and we pass it around in hospitals a lot. But the real big danger in Staph aureus is because it's so common, it's had a very large ability to pick up antibiotic resistance along the way. As a result, it's becoming more and more difficult to treat, and because it's so difficult to treat, people have a tendency to want to vaccinate, because what's the easiest way to treat something is never to catch it in the first place. So one of the concepts that keeps coming up over and over again is, how are we really looking to vaccinate against anything? And vaccination is a tricky topic because historically, we've been fairly successful in vaccinating. We've successfully eradicated smallpox. That's the only one, by the way, that we've successfully eradicated. So we're very, very close on polio. Some people are projecting that that'll be gone within about 10 years. It's still, unfortunately, pretty prevalent in Pakistan. But regardless, up until recently, we've had a pretty good control over things like measles, mumps, rubella, thanks everyone in California that doesn't vaccinate their kids for the recent outbreak there. So one of the things that we tend to get bogged down in is the human side, the human health side of vaccination. And, that seems like it would be a really important thing to get bogged down in. We talk about how to cure people of things. The issue sometimes is that as immunologists, as vaccinologists, we have a tendency to want to cure people as fast as possible, and that is a noble goal. The problem with that is sometimes in order to do that, rather than focusing on the real basics of immune stimulation, how do we get an immune system kicked off, we instead rely on the same methods that we've used over and over again to vaccinate against old bugs. And that has worked, like I said, in the cases of smallpox and polio, so it's a reasonable place to start. But we've come across lots of pathogens now, HIV as a prime example, that have been incredibly resistant to the generation of immunity by traditional vaccination methods. So the question is, why is that? Well, there's a number of reasons, and a lot of it's pathogen specific, and there's a whole slew of things that you could point to. But one of the things that I've suggested in the past, and I suggested in this last discussion, is that perhaps a B-cell mediated view of things is not always the right way to go. We love antibodies. Immunologists love antibodies, or at least vaccine-based immunologists love the idea of producing antibodies and sterile protection so that the bug never catches hold and, everybody goes along their way completely resistant to the pathogen. So that's all great, except that certain pathogens are clearly extremely resistant to antibody-mediated sterile protection. Unfortunately, staph seems to have been one of them. And the point of this paper was to start to address why staph is one of them. So what is it about staph that's preventing us from generating a really good, robust antibody response against it? So one of the proteins that's been really focused on in the staph field in the last several years is this protein called staph protein A. Now, several people have published on staph protein A, and they've talked about how it's a virulence factor and it's important in staph control over the host immune system. And several people have even suggested that staph protein A acts as what we call a superantigen. The reason that it's so resistant to B-cell mediated protection is it's actually overstimulating B cells, but it's not overstimulating specific B cells that would help you protect against staph. It's overstimulating lots and lots of B cells, almost 30% of B cells. And so what you get is this really non-specific activation of a huge arm of your immune system. And so the idea sort of is that in all of the confusion of all of this activation, staph sort of just goes along undetected somewhere around the bottom, just sort of waiting to pop up. That's a terrible metaphor. It doesn't actually work like that. Essentially what happens is there's a big storm of activation and none of it's really specific for staph. So let's just leave it at that perhaps. So the authors contend at the beginning of this paper that because staph protein A is basically usurping this B-cell antibody-mediated arm of the immune system, that perhaps this protein is actually coercing it enough where if you knocked out the function of this protein, if you knocked this protein's ability to activate, non-specifically all of these B cells, then perhaps you could generate a quote-unquote real antibody response against Staph aureus. And hopefully that antibody response would be the one that's protective. And so the reason that I bring that up is because the authors mention a paper several times in their own manuscript. And that paper is, I believe Kevin is posting it now. It's called The Role of Protein A in the Evasion of Host Adaptive Immune Responses by Staphylococcus aureus. This is a paper out of the University of Chicago Department of Microbiology. First author is Fabiana Falughi. And so in this paper, basically, it lays out some of the groundwork of the paper that we discussed in our main episode. But what they're really trying to do is they're trying to take a look at staph protein A, very similar sort of publication. They're looking at staph protein A, and they're asking, is staph protein A actually important in immune evasion? And if so, how is it important? So lots of the same sorts of questions. And so what they find is that if they mutate certain parts of staph protein A, as you'd expect, you mutate the functional parts, and the effectiveness of staph protein A goes down. So if you don't have staph protein A, staph fares less well when it's trying to infect something like a mouse, which is what they're using as far as this study is concerned. But what's really interesting about this study, and I think it's something that we should think about in a broader context of vaccination, is they do a really interesting experiment. I'm not quite sure why they did it, but they did it anyway. They took animals that lack B cells, they lack, as a result, antibodies, and they infect those mice with normal staph that has normal protein A. And what they find is that somehow that staph fares less well than if that staph had infected a wild-type mouse. So they dig a little deeper, and what they ultimately find is that staph protein A is indeed important in preventing the immune system from recognizing staph, but that effect is mediated by the presence of antibodies. So if you add back antibodies into a mouse lacking antibodies and then infect with normal staph, the infectivity goes up again. So basically what they're showing is that not only is staph protein A using antibodies to sort of hide itself among the adaptive immune system, but staph's survival actually depends on the presence of antibodies. Why is that interesting? Well, it's interesting because it means that somehow, if you don't have antibodies, animals are better at clearing staph. So I think that brings up a more fundamental question about how we approach vaccine design, or how we think about, vaccination. If staph requires antibodies in order to hide itself, quote unquote, from the host immune system, and if eliminating those antibodies actually allows the host immune system to detect staph more readily, and in the absence of antibodies, our immune system is perfectly fine at clearing staph, then why is it that we are so focused on generating an antibody response against Staph aureus? Is it not realistic to take a step back and really think about, okay, well, if in the absence of antibodies, we seem to be doing a fine job of detecting and clearing staph, how to potentially boost that responsiveness? Or can we temporarily take this protein A mediated protection offline with something like a small molecule inhibitor, right? That would then allow those normal natural clearance mechanisms that are not antibody mediated to kick in. So again, I don't want to say that it's not worth pursuing something like an antibody-based vaccine approach to Staph aureus. Clearly, lots of people are doing it. Clearly, they know the field a lot better than I do. But I do think sometimes we get caught up in trying to do the same thing over and over and over again. We must produce an antibody against this target. We must produce an antibody against that target. And if we could only produce the right antibody, then maybe we could prevent this disease. And maybe in some cases that's true, but I would like to see, hopefully, a little bit more focus in the future in ways that the immune system is dealing with these pathogens independent of a B-cell humoral immune-mediated response. So with that, I'm sure that we'll talk about that lots more in the future. Hopefully, I haven't confused everybody. I know talking about 2 different papers in 10 minutes is a little overwhelming. It certainly was difficult for me to keep everything in my own head. If it totally didn't work, let me know. We'll change it a little bit for next time as far as the format of these things go. But until then, hopefully you're enjoying this and other minisodes around the Immunity site, and we will see you next time.